Hello everyone. My name is Dhaval Jakani and I'm a principal technology architect. With me, I have Amrish Raze, who is also a principal. We both are part of the open source group within the Infosys modernization practice. Our practice is a technology horizontal within Infosys, which gives us a unique vantage point to work with clients across different verticals. Today, we're going to talk about different use cases where the industry sees the demand of edge computing. Our experience on one such implementation in the retail industry, our experience in modernizing the architecture with Couchbase Mobile. Along the way, we'll share our learnings and best practices. Lastly, we'll leave you with what we believe where the industry is moving in adopting modern architecture patterns and use cases on the edge. Let's begin with what edge computing means. Edge computing is bringing computation closer to the location where the transaction is being processed. This could be a mobile device like a phone or a tablet processing customers' data in the field, or a POS system in the store. In the retail setting, this could be a field agent taking orders from the store using a handheld device, or an employee in the store checking if they have more stock of an item in the store. It could be an agent checking a customer into a flight or a cruise, or a device in the train requesting customers to fill out a survey about the conditions of their bathroom. It could be a system in the pharmacy helping a customer with their prescriptions, or a device carried by emergency services like an ambulance that can pull up a patient's medical record and feed in critical information about the patient for the hospital when they arrive there. The possibilities are endless, and we are just beginning to scratch the surface of what is possible.
Today, I'm going to talk about a use case in a retail setting. A large customer has thousands of sales reps who are responsible for taking orders from retail stores and fulfilling those orders. The typical day starts with clocking into their shifts on a handheld device and checking what route they have been assigned to for the day. They drive their trucks on the route and visit stores that they have been assigned to. At the store, they fulfill previous orders by bringing products to the store and sometimes even stocking the product on the shelves. They check what items the store is running out of and place orders. Sometimes they need to stock the orders immediately if the store is critically low and they have some excess quantity of the item on their trucks. While their entire interaction at the store sounds simple enough, there are a lot of things that are needed to make this happen. First, the sales reps needs a list of customers to visit. Then they need data about that customer, their previous orders which need to be fulfilled, their ordering patterns, catalog of items that the store carries, including special or exclusive items, etc. They need prices for the items and any special promotions or discounts that are offered to the store. Prices and promotions could be different for each store they service. In summary, there's a lot of master data that the sales rep needs to process orders. This data may change dynamically throughout the day, but a lot of it is refreshed daily and is required at the start of the shift. So having looked at the use case, let's see what it takes to realize such a use case. To begin with, the handheld devices that the sales reps are using must have all the data that they need to do their job. The app they use to service the customers should work in an offline first mode. That is, they should have all the data that it needs to take an order at a customer location like a store or a warehouse and not depend on a network connection like a cellular signal or Wi-Fi. But the device should also be able to sync data with the servers whenever connectivity is available. The backend servers should receive orders that they take in store, and the app should receive the latest information about product pricing, customer insights, etc. Typically, this data is exchanged over a cellular network, and it is critical that the amount of data exchanged over the network is reduced. This not only saves network cost, but also ensures that the data is quickly received by the device when the network is available and not make the sales rep wait for the data to sync. As you would realize, data routing is very important and can be very complex. We want each device to have exactly what it needs and nothing more. And lastly, the software powering this must be enterprise grade. It must be robust and provide a seamless experience to the user, irrespective of whether they are online or offline. Having looked at the use case, let's quickly review the customer's current solution. Simply put, it is an aging system designed and developed decades ago, which runs on legacy handheld hardware and software. It is a tangle of various APIs and web services for downloading data on the device, sometimes in the form of large data files, and processing them on device. Entire datasets are loaded in the device memory for all customers that the rep would service. There really isn't a sync solution in place, and data replication is largely batch-based. So, what are the challenges that the customer is facing? To begin with, the current architecture is monolithic and is becoming extremely difficult to scale. It is virtually impossible to add new features, and any changes to the software requires a lot of time and effort. There's no real sync framework to sync data. Everything must be custom developed and managed. Data is stored in relational data structures. Multiple tables need to be synced to receive a fully workable data set. Any failures result in loss of data integrity and prevent the customers from being serviced. In a nutshell, the sales rep has a very poor offline experience, and developers have an extremely challenging time keeping the system operational, let alone adding new features to help grow the business. Having looked at the challenges with the current solution, let's talk about what enterprises expect from their edge solutions. Offline first. Apps should allow the user to go about doing their job irrespective of whether they have a network coverage or not. The user experience must be seamless. Local storage. Offline first needs the app to have a good local database. They should be able to save data from the server locally and query the data as and when needed. Synchronization. Having a local storage is not useful if the data in the local database is out of sync with the server. The sync framework must be able to seamlessly keep the local storage on the device in sync with the server. It must be able to handle all the network idiosyncrasies and provide a reliable data sync guarantee. Having looked at the current challenges and what enterprises expect from mobile devices, let's talk about a reference implementation for such an architecture. The architecture shows a retail use case, but it can be applied to any industry. The users use an app that is running on a mobile phone or a tablet. The local storage and sync mechanism is provided by Couchbase Lite. We use Couchbase Lite because it is a lightweight embedded database that can seamlessly sync data with the cloud. It provides full CRUD and query capabilities and features like full text search, data encryption, peer-to-peer support, and importantly, cross-platform portability. On the server side, we have a global load balancer directing traffic to the appropriate data center. This could be geolocation-based or latency-based routing, connecting to the best region in the cloud. A DMZ layer in the cloud provides DDoS protection, firewall, and gateway services to route incoming traffic to the correct backend service. Couchbase Sync Gateway sits in a private subnet and handles data synchronization with the mobile devices running Couchbase Lite. Couchbase Sync Gateway is a secure web gateway that enables data access and synchronization over the web. It provides a robust automatic sync capability and excellent support for fine-grained data routing and security so that the right data can be synced to only those devices that really need it. It also provides APIs to integrate data with external store and non-CB Lite devices. Sync Gateway stores data in a Couchbase database server cluster. Couchbase Server is a distributed NoSQL database that delivers unparalleled performance at scale. With a memory-first architecture, Couchbase Server excels at supporting mission-critical applications at scale while maintaining sub-millisecond latencies and high availability. The Couchbase Server is front-ended with a full complement of microservices, providing services for managing data, processing orders, powering the website, ingesting and processing data coming in from the backend master data sources like mainframes, ERP systems, data warehouses, etc. The architecture demonstrated here is an active-active architecture with sync gateway replication between SGs in multiple data centers, taking on the responsibility of keeping data in sync. If the requirement does not necessitate a full active-active deployment, this could be easily replaced with an active-passive or an active hot standby architecture where data replication between data centers can be managed using Couchbase XDCR at the database server level rather than at the sync gateway layer. So we talked about the reference architecture. Now let's talk about some of the highlights of our implementation. Let's begin with unit of work. When you start data replication, Couchbase tries to sync all available data on the channel you choose. But if there's a network failure, whatever data was synced is retained. When network connection is re-established, Couchbase starts syncing data from where you left off. However, there are situations where you want an all or nothing behavior. For example, there could be thousands of promotions applicable to a given customer. We want to ensure consistency when we apply promotions to their orders. We are okay to use the previous set of promotions on their orders, but we cannot mix old promotions with new ones. Imagine what would happen if half the promotion documents were synced to the device and network connection was interrupted. The promotions dataset would be in an unusable mess and the orders could have incorrect results. While there is no out-of-the-box solution for this, we were able to take a pragmatic approach at solving this problem. We sync a document to the mobile on a special channel to let them know that a server-side data refresh is in progress. In this case, the device continues to work off the data it already has and does not try to pull data from the server till it receives another signal from the server indicating that a data refresh is complete. This ensures that Sync Gateway has completely imported the latest promotion dataset and is ready to work with the mobile. The mobile devices then sync the data down to a staging Couchbase Lite database on the device. If sync is interrupted, the staging database does not have a full set of documents that comprise a unit of work. However, the production Couchbase Lite database is intact and the device can continue work using the previous set of documents it already has. Once the documents in the unit of work are synced to the device, we do a local Couchbase Lite replication to pull data from the staging database to the production database on the device. Local Couchbase Lite replication is a great feature that provides capability to take a backup of your Couchbase Lite database. We use that feature to solve our need to maintain consistency of our Couchbase Lite production database. All right, let's talk a little bit more about the staging database. In addition to solving the unit of work problem, we use the staging database pattern for most of our data. While it does have an additional overhead of staging data in another Couchbase Lite database, it gives us some advantages. The device can make the most opportunistic use of network availability and get all the data that it needs. A typical transaction, like taking an order, involves multiple steps and references several related documents like product, pricing, promotion, inventory, etc. It would not be good if the data required to complete the order was changed while the order transaction was being processed. Having all data synced to a staging database gives us full control over our data and does not interrupt the transaction that the user is working on. We are able to sync data from the staging database to the production database at an appropriate time, and we no longer depend on network conditions to determine when that appropriate time comes. We were able to achieve what I describe as pseudo asset compliance by taking this approach. The next thing that I'd like to talk about is our server database backup strategy. Out of the box, Couchbase provides a utility called CB Backup Manager for taking database backups. We implemented a custom cron job that runs on our Couchbase database node. It takes hourly backups of all buckets. CB Backup Manager takes incremental backups of the database so we don't end up having a huge database image of our entire database every other hour. We also use the CB Backup Manager compact feature to further reduce the size of our backup. We also use the merge feature provided by CB Backup Manager. We use this to retain hourly backups for 2 weeks and then merge the oldest hourly backup into a single database backup. This gives us the ability to go back to any hourly point in time for the last 2 weeks, in addition to having a full database backup available. The next thing that I'd like to talk about are some accelerators that Infosys brings to the table in addition to our vast experience in architecting and implementing mission critical applications. For NoSQL databases, we have tools like our NoSQL Data Modeler and Infosys Data Model Converter, which is a productivity booster for converting relational databases to NoSQL databases. We also have developed a great tool for working with Couchbase Sync Gateway, which I would like to now demonstrate. Couchbase Lite Tester is available from our GitHub repo and is free to use. In a typical Sync Gateway implementation, the core component interacting with the Sync Gateway is a mobile app, which has an embedded CB Lite database. While this makes complete sense in a production environment, testing data sync requires a fully developed mobile app. Creating a mobile app is time consuming and is often done by a different set of developers, those that are not responsible for the data sync. Thus, it is not a practical approach to wait till the development has been completed to test data sync functionality. The data sync team needs a robust way to build sync rules and test these without depending on the mobile app development teams. Additionally, there may be situations where we need to create pre-built CB-Lite database images and deploy them on the mobile devices, or read data from a CB-Lite database file from another device for debugging or testing purposes. The CB-Lite tester provides an intuitive UI and makes all of these tasks possible and simple. For the purpose of this demo, I have a Couchbase server running in a Docker container on my local machine. I also have a Sync Gateway instance syncing with the Couchbase server, and again, this is running in my local machine on a Docker container. Let's look at the CB-Lite tester tool. When you open the tool, this is the interface that you're going to get. The first thing that you need to do is go ahead and set up the sync gateway that you want to sync with. The tool does allow you to set up your environment. You could have a drop down here, put in your dev, QA, production instances, and your sync gateway details will get automatically populated. Or you could just type it in the way I have done it here. Right, so type in your Sync Gateway URL. Since I'm running Sync Gateway in a Docker container on my local machine, the URL is localhost. It's listing on port 4984. SyncDB is the name of my Sync Gateway database. If I had SSL enabled, I could choose the WSS scheme here and then provide a certificate to sync with. The next thing that you have to provide is the location where your CB-Lite embedded database is going to be created, and optionally the last thing that you could provide is a URL where your Sync Gateway admin APIs are exposed. Now, doing this in production is generally not a good idea, but in local machine you could potentially expose your admin APIs outside, or you could do something like have a reverse proxy in front of your admin APIs or an SSH tunnel, and that way you could expose your admin APIs outside the VM on which Sync Gateway is running. So once I've set all of this, I'm going to click on save, come in here, type in the username and password which have been set up on the Sync Gateway. The next thing that you see here is the sync channels. By default, all the channels that the user has access to will get synced down to the tool. But what you could also do is come in here, and if you have your Sync Gateway admin URL set up correctly, you should see all the channels that the user has access to. In this case, I'm not going to select any channels, but you could, in case you don't have the Sync Gateway admin API URL set up, you could just click on add channel here, type in whatever channels that you want to sync with, set it in here, and you should see it in the drop down here, and you could just select that channel and just specifically sync with that channel if that's what you want to do. For now, I'm going to leave it blank and sync all channels. Replication mode, you could do a push replication, pull replication, or you could do a push-pull replication. The default is pull. I'm going to leave it at default for now. You could also turn on continuous sync if that's what you want to do. For now, I'm just going to do a one-shot replication. I'm going to hit sync, and what it does is it goes against my Sync Gateway and pulls all the documents that this user has access to. I click on load full documents and I can see all the documents here. And then I can potentially, click on any document, open it in here, search through the document. I could go in and change any attributes here, save the document. When I save it, the document gets locally saved to the CVLite database. What I could also do next is change the replication mode. This time I'm going to do a push and pull replication, and I'm going to sync this. So that way the document that was here gets pushed up to the sync gateway, to the Couchbase database. And as you can see, the document 3 was updated based on whatever we changed in the CVLite tester tool. This is super useful if you want to change a few documents and sync them up, or you want to test your sync gateway function. You might have made any changes to the sync gateway function and you want to test out the functionality that you implemented. This is a great way to test it out. And then if you have a lot of documents that you're pulling through, you could just put in the name of the document here and search it that way. So it just makes it easier to look at your data. You could also go in here, add a new document. And push that, and you should be able to see that the new document got synced to the server. Alright, the other thing that you could potentially do with the tool is, if you have a CVLite database file from another device that you want to debug with or test with, you could download that CVLite database file to your computer. And then what I would do is go into the settings, choose a different database. In this case, I'm just going to point it to the file that I may have downloaded from a production device that I want to view in my tester tool. And then I just click on reload table, and it should pull whatever documents were available in that database. The interesting thing now is you could potentially change your replication to pull and push and sync it up to the database. And as you can see, the document is pulled here. And this is super useful if you need to move data between two CVLite files. Potentially what you could also do is sync data from a QA instance or some other instance down to a CVLite file on your local machine, and then use that database image to load to your production mobile devices if that's what you want to do. So that way you will be able to deploy pre-built database images to your production devices with all the data already on it. And then the next time you do a sync, you just get the delta of what was changed on the production server. So that's just a super efficient way of building pre-built database images. So the tool can help with that as well. So those are the overall features that this tool currently supports. We use this extensively in our testing to make sure that all the new interfaces that we are developing perform exactly the way we wanted them to, and we are looking forward to everyone jumping on and using this tool. Hopefully it will help you with your stuff as well.
Having looked at some of the features we implemented, I would like to talk about what we learned from this experience. Bidirectional syncs is complex. You end up having to deal with conflicts in your data, and simple conflict resolution rules don't always work, especially if you're dealing with high value data. While Couchbase does provide great support for conflict resolution and allows you to implement custom conflict resolution, there is generally simpler options to achieve what you need. For example, if you're uploading orders from mobile device to the server and want to send an acknowledgement to the device that the order was received, you could create a separate receipt document instead of updating the order document and sync it back to the device. While this may not always be possible, it is best to try and keep your data as simple as possible, avoiding bidirectional and sticking to one directional replication wherever possible. The next thing that I would like to talk about is WebSockets. Couchbase uses a WebSocket based replication protocol. While it makes for a great sync protocol, it brings some challenges with it. Most network and cloud infrastructure is built to work with HTTP protocol and REST APIs. WebSockets are not always a first class citizen. We found that some network components require configuration and fine tuning to make it work, while others simply don't support WebSockets. Doing a POC in your environment and ensuring that all your components in your stack support the protocol is very important. The sooner you do this with all network components, the better it is. All right, moving on. Let's talk about cross data center replication using Couchbase XDCR in the context of Sync Gateway. XDCR is a great tool for replicating data across data centers. However, if you're using Sync Gateway to sync data and support an active topology, you should not use XDCR on the bucket used by Sync Gateway. This is because Sync Gateway stores all the Sync Gateway related metadata in the same bucket, and replicating that data to another bucket, which is also used by another Sync Gateway, will cause chaos. Sync Gateway replicate is your way out in case you need to replicate data across data centers while using Sync Gateway and an active topology. While this is not necessarily a deal breaker, it certainly is something to keep in mind while designing your solution. The next thing that I want to talk about from a learning standpoint is attachments. One pattern for dealing with attachments is to store attachments in a blob storage like AWS S3 and embed a link to the attachment in the document that you're syncing. While this works great for a lot of use cases, it does have the problem of your documents and attachments being out of sync. Consider a scenario where the device pushes order successfully to the server via CB sync, but was unable to push the attachment to S3 due to a network interruption. The server will try to process the order and find out that the attachment is missing. Couchbase Sync can be used to overcome this kind of a situation. Couchbase Mobile provides the capability to sync attachments like images, PDFs, videos, etc. between the device and the server. And the protocol is smart enough to not sync the same attachment again if it is referenced in multiple documents. This is great if you're dealing with web assets like images, which every device may need. However, there is currently no garbage collection solution for deleted attachments on the Couchbase server, as it cannot keep a track of which documents share the same attachment. You must implement a custom solution to explicitly clean up attachments from the server when you delete the document containing it. Again, this is not the end of the world, but something you need to be aware of so that obsolete documents don't eat up storage on your server. Alright, so let's talk about some of the benefits that we are able to realize using Couchbase Mobile. The biggest benefit of using Couchbase Mobile is that you get a robust sync engine and a lot of enterprise features out of the box. We have seen a 3x improvement in go-to-market time using Couchbase Sync versus having to manually build some type of API-based sync. And even if you do manage to build a custom solution, adding enterprise features like Delta Sync, conflict resolution, etc. is generally beyond what most companies would want to take on in-house. Enterprises don't always have unlimited data plans, and even if they do, it is not very efficient for a field agent to wait for a huge data payload to finish downloading before they can go about doing their job. With excellent data routing capabilities, we can sync exactly what a user needs. Moreover, Couchbase Mobile also supports field level delta changes, which means that the whole document does not get synced to the device when a couple of fields change on the document. We have seen as much as 80% bandwidth efficiency with the use of Couchbase Mobile. In most cases, we have seen a break-even using Couchbase solution within 1 to 2 years.
As today's global enterprises look more and more at edge computing to address sensitivities around bandwidth, cost, and latency, they are recognizing the intrinsic value of capturing and using edge data in their business critical applications. A lot of innovative features of data center and cloud are now available at the edge. The containerization advancements with lean footprint for the edge devices are making any workload viable to run on the edge. More traditional workloads are getting realized with modern architecture, especially by customers with stores remote offices or warehouses, example, the retail and manufacturing enterprises. Analytics and machine learning capabilities to derive real-time value out of data at the edge has drawn attention and interest from our customers. With predictive query APIs on Couchbase Mobile, Couchbase product team is making the right innovations on this capability. With this, we come to the end of our presentation. Please do reach out to us for any questions. Thank you.